the earlier classes. So these were the formulas, no? Expression for J equal to E by rho, there's the Ohm's law, then V equal to IR, then R equal to rho L by A. Okay, and the expression for this speed, J equal to eta Q into VD. This is the expression for the current density. This one. Then we had some other formulas, no? Relaxation time, then resistivity, we brought it. I'll write down directly. After solving, the relaxation time will be dependent on mass of electron, resistivity, concentration of free electrons, and the charge of electron. This tau is called as relaxation time. Rho is the resistivity, not density. And eta is concentration of the free electrons. There's one formula you do remember, which will help us a lot. Okay, let's come for this one. As we increase temperature, what will happen? What effects will be produced on the conductor now as temperature increases? As temperature of conductor increases. Then what we notice is this will be the electric field. Who will provide this? The external source, like yesterday we have seen. This is a cell. So, and this was the electron. So what is the path of electron? It will be zigzag path. There will be random motion. The net displacement due to random motion will be 0. It's due to under the influence of electric field, it undergoes drift here. So it will move with a drift speed Vd. Now as I rise the temperature, what will happen to electron now? So as I rise the temperature, the thermal agitation of electron will increase. It will encounter more collisions. Due to more collisions, what will happen? The relaxation time. What do you mean by relaxation time? The average time spent by electron without collision, or time taken, time interval measured between two successive collisions. It's the average, that one. So as I rise the temperature, so definitely what will happen? More number of the thermal agitation will increase. Due to increase in thermal agitation, more collisions will occur. Due to more collisions, what will happen? The relaxation time will decrease here. Then if relaxation time decreases, what should happen to this speed? This speed also is going to decrease. So what is the effect of as temperature of conductor increases, what all we can see? That this speed first tau relaxation time decreases. Second, this speed. Now this is a data you are supposed to remember, very important for you. Can be asked in exam. Then what will happen to overall resistance? More number of collisions, greater the resistance, so resistance increases. There's a one information I'm sharing it. As temperature of conductor increases, what will happen? The thermal agitation will increase. Thermal agitation means more number of collisions the electrons will undergo when it moves from one end to another. And number of collisions increases, so definitely the relaxation time decreases, the speed decreases, and resistance will increase. Why resistance? Because it will encounter more resistance to its flow. And these are some in books. What happen? You do have questions related to this. It's just information based, nothing else there. Time being, like actually we don't have any mathematical proof here. Straight away, I'm just projecting it. How that relaxation time is related already we derived yesterday in Ohm's law. From there, I brought this equation. Okay, got this one. So this is about the thing. Okay, this cell, let's come back to cell. So shall I say that what will happen to electron? So the electron here, the cell does positive work, no? And because of that, the electron, or say the positive charge inside the cell will get energized by the cell. The cell does positive work. So it will get enough energy. With that energy, what will happen? The positive charge will enter the conductor because of applied potential difference. So now, so it starts moving. So when it is moving open, it encounter collisions like this. So once it kinetic energy becomes zero, it will be pulled by the negative terminal of the cell. So this was the overall sequence it happens. Now this everything, there's a physical diagram. The symbolic form we use like this. This is a symbolic form. This is called like a EMF of a cell, right smallly. What is E? E is called as EMF or electromotive force of a cell. Electromotive force of a cell. What will be unit? Unit will be in volt, 10 volt, 5 volt, 6 volt. Suppose say this is say like a 2 volt I'll apply it. Then how much of EMF will be? 2 volt. Go there, I'm bringing the word electromotive force because inside the cell, the chemical reaction will occur. Because of that, what happen? The positive charge will be displaced from negative to positive terminal. Some sort of force is acting. That's why the electromotive force. That force, what happen, will make the charge to flow through a wire. It will be like this. And when it encounters resistance, what it do? The charged particle will give out its energy in the form of heat due to inelastic collision. Once energy becomes zero, will be attracted by negative terminal. So here, the moment of positive charge will take it because we know no moment of positive charge. Since our electrostatics, we started with test charge, no? So you can assume opposite to flow of electron, there'll be flow of a charge. Got the idea now? So this will be, so here, this is the resistance. This is the electrical circuit. This is the symbolic form or what you can call electric circuit. And this is the physical one, what you are seeing. So every time drawing this physical one, no, so we just, the overall the resistance of the conductor, we just show by a symbol zigzag line like this. This is a resistance and the EMF of cell, positive terminal. What do you mean by the long one? Positive terminal. The shorter terminal is the negative terminal. So if you buy that Duracell every day, no, there will be written 1.2 volt. What is that potential difference? These are called like terminals, A and B. This is the thing. So what is a cell? It will convert chemical energy into electrical energy. What is a conductor, resistor? It will convert the electrical energy into heat energy. Further, the heat energy will be converted into either light or any other form. It depends upon how you are using this resistor. Okay, this is called like a now the resistor. Got the idea now? Okay, let's do one thing. Few more basics will work out. If the conductor is of shape, okay, I'll connect across a cell. Now look at the conductor. So its shape is some conical shape, no, truncated cone or the tapered rod. So now the current I will flow in this direction. There's a flow of current. Now I am interested in few quantities like what will be the disk speed as it moves from one end to another end. Let me take two elements. This is the one element. Okay, now what will be the drift speed? Let me give the position for them. Let this be the element 1, this element 2. Both are having same area of cross section. Yeah. What will be the drift speed? What will be the first current? So the same current will flow. I should not show arrow, just the current, that one. So here area of cross section is A1, this A2. So what will be the J1 equal to? J1 equal to I by A1. J2 is equal to I by A2, current density. And how will be how current density should be directed? It should be directed normal to the surface area. And whatever the current in circuit will be towards like that one. Same current will flow. So now you look at this A1 less than A2. So what will happen to J1? Greater than J2. What will be the disk speed? So we know disk speed depends on like a current density. What is the formula? Eta Q VD, no? Concentration of free electron, the same iron. Everywhere the material is having same eta. Q, charge of electron, current density. So current density at 1 greater than 2. So the speed of the electrons at 1, it will be greater than that of 2. Just do comparison. Then what about the resistance? We'll compare. Both are having same thickness. Let's assume thickness is same. Then what is the resistance? Rho L by A. Thickness is same, area of cross section of different. So A1 less than A2. So R1 greater than R2. What about power dissipated in that elements? dP1. Power equal to I square R. Same current. So dP1 P1 and P2 are powers. Electric power dissipated across that elements. What about the electric field? Can we say anything about electric field? J equal to E by rho. J equal to, so J1 greater than J2. So definitely electric field at 1 will be greater than that of 2. Once you know electric field, you know the distance dx, no? The thickness is same. E equal to V by L. So what is the potential drop? Potential drop delta V1 should be greater than that of delta 2. What are delta V1, delta V2? Are potential drops. All the things in every numerical now, try to analyze this particular thing. What will happen to current density? What happened to disk speed? What will be the electric field? Then you can compare the resistance, power dissipation, even the potential difference also. Fine. If the conductor comes of some other than cylindrical shape, then so like this what happen, we can analyze the different parameters. Okay, these are very popular questions are there. So where it is the conductor, the area of where it is narrow, no, there what happen, the speed will be more. Potential drop, potential difference, potential difference. In electrostatics we had, no, the potential difference. Now you can ask questions. The conductor is equipotential. Yes, it is equipotential due to static charges. What is the state of charges here in the